Good morning, good afternoon, good evening, whenever it is you're watching. Thank you for watching. It's Miss Hernandez. We're going to be covering 6.2 Mendeleev's periodic table. And with me, I am working again with fifth period. They are my awesome assistants for the day. So, I need somebody here from fifth period to help me out with the introduction.
Memes.
Okay.
One useful way is to use flashcards. You write down the vocabulary words, the foreign language terms, the math formulas, the chemistry reactions, anything you want to learn. Then you sort these cards into categories, topics that go together. This organization of uniform information helps you see patterns in the material so you can tie different ideas together and make better sense of them. The periodic table was first built using a set of cards. With this strategy, Mendeleev could organize and rearrange material until patterns emerged.
All right. Thank you, Alexia. So when you're studying for a test, one of the approaches or one of the methods that people do or use to study is they make flashcards, right? They make flashcards. They put information that they need to remember on these flashcards, and they probably take them everywhere they go, right? And then when they have a chance, they'll spread them out and they'll be like, okay, what information do I know that I do not study? And then they take all of those flashcards and they move them out of the pile, right? Because if you already know the information on one of those flashcards, you're not going to be studying over and over again. You're going to be studying the information you don't remember, right? But in this case, when Mendeleev was trying to create his version of the periodic table, he put all those 68, 63, I don't remember, elements on flashcards, and he spread them out on a table, and he moved them left and right, and he moved them everywhere, trying to see if there was a pattern, trying to see if there was a way where he can arrange them so that it's easy to understand. Okay, so let's see what he came up with using this strategy. So Mendeleev's periodic table. So who was Mendeleev? He was a Russian chemist and teacher. His full name was Dmitry Mendeleev. And in 1869, he published his periodic table of elements. 1 year later, the following year in 1870, here comes Lothar Meyer, a German chemist who also published a periodic table that was similar but yet different to Mendeleev's. Now, Mendeleev is generally given more credit than Meyer because, of course, his table was published first, and because there were several key insights that he made regarding that periodic table. So there was some very specific ideas that he had that Meyer did not. He also made predictions that later came true, you know. So let's find out what exactly his periodic table was about. Okay? And here you have a picture of Mendeleev. So, Mendeleev was in the process of writing a chemistry textbook for his students, and he wanted to organize all of the known elements at the time according to their chemical properties. So, he already had an idea as to how he wanted to organize these elements. He just wasn't sure if it was going to work, right? And he couldn't really figure it out just yet. So he famously organized information for each element on a separate note card or flashcard. And that way they were easy to rearrange as he needed. He was able to, he discovered that when he placed them in order of increasing atomic mass, there was certain similarities in the chemical properties of some of these elements. Okay, and they repeated at regular intervals. And this type of regular intervals or repeating patterns is known as periodic. So if you've ever seen a pendulum, does everybody know what a pendulum is? When you have a clock and you have that arm that's hanging and it goes back and forth and it rocks back and forth and it ticks, that's a pendulum. So if you're talking about the interval that a pendulum takes, it's also periodic because it will go a specific distance back and forth every second or every minute. It just depends on what type of clock you have or what type of pendulum is swinging for that clock. Another example of periodic is how the moon goes around the earth every day. It's periodic. We know that it's going to happen every single night. That moon will rotate around the earth, right? Now, this picture right here shows the 1869 periodic table that Mendeleev published. And the way it's grouped, you can see some similarities between some of the elements. If you like kind of like tilt your head to the side, you can kind of see today's periodic table, except his was vertical instead of ours that usually is more horizontal in its organization. Okay. Now let's go and talk about Mendeleev. So you'll notice here that it starts off with hydrogen. It goes on to beryllium, boron, carbon, nitrogen, oxygen, and fluorine. And you'll notice that the mass of each of these elements increases as you go down, right? In this case, you start with 9, you end up at 23. In the second column, you start at 24, you end at 75, and then so on and so on and so on. Um, in the figure above, atomic masses increase from top to bottom. So you'll have low atomic mass, and then as you go down, 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 you'll see that that atomic mass will increase. There are successive columns going from left to right. As a result, elements that are in the same horizontal row, elements that go side to side, are in groups. And why are they in groups? Because that the reason is because they showed similar chemical properties. One of Mendeleev's insights is illustrated by the elements tellurium and iodine. So remember those key insights that we're talking about? One of the key insights you can see between elements tellurium and iodine. So let's look up tellurium and iodine. Tellurium is right here with 128. Iodine is right below it at 127. Didn't it say it goes from less or smallest to biggest as far as atomic mass goes? Why is tellurium, which weighs 128, before iodine, which is 127? Let's look at that and let's analyze what's happening. So here it says, notice that tellurium is listed before iodine. Okay, we talked about that. Even though the mass is higher. Okay, we talked about that. Mendeleev reversed the order because he knew the properties, the chemical, the way it acts, the properties of iodines were a lot more similar to fluorine, chlorine, and bromine than it was to oxygen, sulfur, and selenium. So it was all about those chemical properties. He switched those two elements because he knows that iodine reacts just like bromine, just like chlorine, and just like fluorine. Okay, it does not react like selenium, sulfur, and oxygen. So he kind of did a flip flop between those two elements. That is one of the key insights that made Mendeleev's periodic table superior or better. He simply assumed that there was an error in the determination of one or both of the atomic masses. As we will see shortly, this turned out not to be the case. But Mendeleev was indeed correct to group these two elements as he did. So he said, I'm going to flip them. Probably the people who discovered those elements, they made some mistake that those atomic masses are wrong. They're probably in the correct order. Tellurium weighs less than iodine. Um, but that was his thinking. That's what his rationale was as to why he was flip flopping them. He said, I want iodine in the same row as fluorine, chlorine, and bromine because all of those elements react the same. I cannot put it with oxygen and selenium and sulfur because they do not react the same. All right. So that was just one key insight that made his periodic table better. Now, let's talk about another key insight. Notice that there are several places in the periodic table that have no chemical symbol, but instead are labeled with a question mark. So let's go back. You'll see here that you have magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, potassium, calcium, question mark. Question mark, question mark, question mark. And then you have titanium, vanadium, chromium, manganese, iron, nickel, cobalt, copper, zinc, and then question mark, arsenic. And then it continues. Okay, let's talk about those question marks and why he put them in there. Between zinc and arsenic are two missing elements. Mendeleev, without any information, believed that elements with atomic masses of around 68 and 70 would eventually be discovered and they would chemically fit into those spaces. So listed in the table below, here we have a table. Um, Here on the left, you'll have the properties that Mendeleev predicted. On the right is where you'll have that information compared to the element gallium, which was discovered later after Mendeleev. So he said that this element will have an atomic mass more or less of 68. It'll have a very low melting point. It'll have a density around 5.9. And then he said if it were to combine with oxygen, it would probably have a formula of EA2O3. That's what he predicted. Now, if you talk about the element gallium, which was discovered four years after Mendeleev published his periodic table, its properties matched up remarkably well to Ica aluminum. Okay, and it fitting into the table exactly where he predicted. So here we go. Let's compare. So gallium, which was discovered 4 years later, let's compare with what he predicted. He predicted that it would weigh 68, gallium weighs 69.9. Very close. Not exactly, but close. He said that the melting point would be low. Gallium melts at 30.15. Mendeleev predicted that the density would be around 5.9. The density of gallium is 5.94. Extremely close. And look at the formula. The formula for Ica aluminum was EA2O3. Look at the formula that gallium makes with oxygen. It is almost exactly what he predicted. So this was one of the main reasons why Mendeleev's periodic table was so much better. Okay. This was also the case with the element that followed, the element that came after gallium, which was named germanium. He made predictions, and they were very close to what actually was discovered. Mendeleev's periodic table gained wide acceptance within his scientific community and earned him credit as the discoverer of periodic law. Element 101, synthesized or created in 1955, is named Mendeleevium after the founder of the periodic table. It would, however, be several years later after Mendeleev died before several discrepancies with atomic masses could be explained and before the reasons behind the repetition of chemical properties could be explained. So there were some errors in the atomic masses, and there was some repetition of those chemical properties fully explained after he had passed away. This is a video about a little bit of a background as to where Mendeleev came from. Check it out. He overcame a lot, guys. He overcame a lot.
Dmitry Mendeleev had a very strange history. You see, he came from Siberia, the backwash of the Tsarist Empire, and he was the last of 17 children. And as a consequence, his family lived in total poverty. In fact, his father went blind and eventually died, leaving his family in tremendous poverty. And then his mother, in one of the great stories of self-sacrifice, his mother basically gave up her life to make sure that her youngest son had an education.
His mother uprooted the entire family and took him to St. Petersburg, where she tried to persuade local universities to take him and train him.
Well, of course, they said no. He's from Siberia, the backwash. And yet, just before she died, she was finally able to get her son into one of the academies that then launched his great scientific career.
As a young man, Mendeleev became famous for his quick mind and quick temper. He was impatient and very argumentative.
He was very driven. He was very determined to do what he set out to do. He was very stubborn.
He also became rather eccentric. He grew a long beard and hardly ever cut his hair, but he was totally dedicated to his work. Mendeleev knew everything there was to be known about the 63 elements then discovered, and he was determined to find out about their relationship with one another. And when Dmitry Mendeleev made up his mind to do something, he didn't give up until he was fit to drop. Though he was a very impatient man, he used to calm himself down by playing patience. The aim of the game is to sort all the cards into the right order and the right suits, which was not so very different from what he was trying to do with the elements. Mendeleev took a sheaf of blank cards and wrote down the names of all the 63 known elements, together with their atomic weights. He began puzzling over his cards, trying to see if he could place them in groups. But try as he might, he could not find a pattern. He was due to leave on a long journey, but he told his driver to wait. He puzzled over his cards a few hours longer. He sent his driver away. Shuffling the cards around the table, he felt sure that he was on the brink of a breakthrough. But after hours of struggle, exhausted, he fell asleep. He began to dream.
Brom, zinc, aluminium, nickel, cobalt,
The halogens.
And as he dreamt, the picture started to become clear. He awoke with a start and arranged the cards in the pattern of his dream. As a result of his extraordinary dream, Mendeleev cracked the problem. And this is what he came up with. A table with all the 63 elements he knew about, all laid out in one big array. What he'd basically done was to put them in order of increasing atomic weight, going across here and then across here and so on. But he'd also managed to get all the families together. Look here, the alkali metals, lithium, sodium, potassium, rubidium, cesium. These are the ones that react so violently with water. Then the alkaline earths, beryllium, magnesium, calcium, strontium, barium. And over on the other side, the halogens, fluorine, chlorine, bromine, and iodine. He was so sure that he'd got it right, that he also made a really important discovery. Just look at these gaps.
Gaps.
Gaps where elements should have been, but none existed. So he made a prediction. He said, and he had the daring to say, that perhaps these are the elements we should look for.
There were several gaps. There was one between aluminium and indium, another between silicon and tin. Scientists aren't usually hailed as geniuses when there are holes or question marks in our work. But in this case, those holes were crucial. Those holes were the things that everyone else had failed to spot, because they signified the positions of elements that hadn't yet been discovered.
He was way ahead of his time. Okay, he did make. So let's close out today. Those gaps were one of the main um, reasons why he's so respected, because he did make predictions that there would be elements discovered that would fit perfectly, and there was, sooner or later, there was elements that fit. Okay, and he was able to group these elements into 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 groups that had similar chemical and physical properties. Now, Mendeleev published in 1869 the first periodic table. His organization of elements was mostly based on atomic mass, but there were also grouped by chemical properties. Mendeleev also made it possible, or he left gaps, right, and predicted properties of elements that had not yet discovered. Okay. Right, let me stop.